This question is from GATE 2019 Mechanical Engineering paper set 2, question number 41. A uniform disc with radius r and a mass of m kg is mounted centrally on a horizontal axle of negligible mass and length of 1.5 r. The disc spins counterclockwise about the axle with the angular speed omega when viewed from the right hand side bearing q. The axle rotates about a vertical axis at omega p equal to omega by 10 in the clockwise direction when viewed from the above. Let Rp and Rq positive upwards be the resultant reaction forces due to the mass and the gyroscopic effect at bearings P and Q respectively. Assuming omega square r as 300 meter per second square and g as 10 meter per second square, the ratio of the larger to the smaller bearing reaction force considering appropriate signs is dash. Let's find out. So we need to consider two effects as given in the question, the gyroscopic couple and the mass of the rotating disc. It's also given that omega p, which is the angular velocity in this direction clockwise when seen from above, is given as omega by 10, and omega is the angular velocity of disc rotating anticlockwise in its own plane. R is the radius of this disc and 1.5 r is this distance between the two bearings, because this is given to be the axle length. So to solve this question, what we are going to do is we'll consider the two effects separately, gyroscopic couple effect and the mass effect, and then calculate the bearing reactions for each of the effects, then superpose one effect on the other, that is we will add the components of these reactions. So Rp in here will have two components. One is because of the gyroscopic and one is because of the mass. So for the gyroscopic one, we will write this as Rpg, and for the mass one, we will write it as Rpm. Similarly, Rq also we can write Rqg and Rqm. So first, to find out Rpg and Rqg, we'll first calculate the gyroscopic couple. So we have gyroscopic couple on the shaft will be equal to I into omega p. I for a disc can be written as mr square by 2. This you need to know, this is a standard formula. Into omega p is nothing but omega by 10. So we have this as mr square omega square by 20. Now to balance this gyroscopic couple, there will be reactions at the bearing, and these bearings will also create a couple in opposite direction. To find that out, we'll use the equilibrium equation summation of moment about point Q equal to 0. You can even take about point P. I have taken about Q. So we can write Rpg into 1.5 times R. This is the distance of point P from Q. Therefore, we multiply this to this force. This will be equal to the gyroscopic couple mr square omega square by 20. Because it has to balance the gyroscopic couple, so both of their directions will be opposite to each other. Just rearranging to find out Rpg, we will have Rpg equal to mr square omega square by 20 into 1.5 r. This is nothing but mr omega square by 30. Let's put the values. R omega square is altogether given to be 300 into m divided by 30. So this is nothing but 10 times m. We have the value of Rpg. Now just considering the gyroscopic effect, Rpg and Rqg should be equal in magnitude because they are creating a couple and there is no other vertical force in this system other than the mass. Mass we are going to consider separately later. So Rqg will be equal to Rpg. They'll be equal in magnitude, of course, opposite in the direction. So Rq has to be downward if Rp will be upward. Rqg is nothing but 10m as well. Now considering the second effect, that is mass of this disc, we have, if we draw the free body diagram of the shaft, we will have the weight of the disc acting centrally, m into g, will be supported by the bearing reactions Rpm and Rqm. Simply applying summation Fy equal to 0, we will have Rpm will be equal to Rqm will be equal to mg by 2. Because of the symmetry, this weight will be equally divided between the two bearings. So now here actually this is minus 10, writing with the sign, RQG should be minus 10m. We are being asked to find out the ratio of larger reaction to the smaller reaction. Now RPM and RPG both are in upward direction. So total reaction at point P will be RPG plus RPM. Added together we have 10m plus m into g by 2. Similarly for RQM we will have minus 10m plus mg by 2. So definitely the greater one is RP. Writing the ratio RP by RQ, we will have 10m plus g is given to be 10. So this is 5 into m, 10 by 2 5 into m divided by minus 10m plus 5m. This is nothing but 15m by minus 5m, which is minus 3. We need to write the answer along with the sign because they have asked us to consider the appropriate sign. Let's go back and fill in this answer. Ratio of the larger to smaller bearing reaction considering the appropriate signs is minus 3. To learn more about gyroscopic action in machines, you can refer to the NPTEL video Module 2, Lecture 4, Gyroscopic Action in Machines. This is from the course Dynamics of Machines. The course is taught by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.